Well, welcome to my lecture on Chapter 8. It's on the central limit theorem. So, by now, hopefully we've had some experience from Chapter 7 with the normal distribution. And Chapter 8 says something very specific. It says something about the sample average. And that is whenever you have a sample average, that sample average has a distribution that's approximately normal. And you need a sample size of 30 or more, ideally, to use this normal approximation. Here's another formulation of the central limit theorem. It says this: if we have independent and identically distributed observations, that's what this says, then the sample average, which is computed in this way, right here, has a normal distribution with mean mu, but there's a critical difference. The standard deviation of the sample average is less. That is the critical thing to know, is that the standard deviation is sigma over n. Here's another formulation, and we'll use this one often. Okay. I thought I'd show you just the central limit theorem with a little demonstration. And you can watch this on YouTube, so I'll go a little bit quick, but I'll just copy and paste this. So here it is right here. It's the Galton board. And what happens, I'll just fast forward, is that we have these balls and they fall in random order, but their most common order is right there in the center. They're going to show us again. So as it's falling, there are these little pins in the middle right here. And each ball falls on the pin, making a random path. And when the balls fall, they fall usually in the center, but sometimes they fall far from the center, here and here. But the most central tendency of the path of these balls is directly under where they're being laid, where they're being dropped, making this nice normal distribution. Okay. So that's just a little bit of a demonstration of the normal distribution. Okay. If you want to watch the rest of that, you can do that on your own time. Okay. And here's an example problem. It says the shape of the distribution of the time required to get an oil change at a local company is unknown. Okay, central limit theorem doesn't care about the distribution of the individual observations, but it says company records indicate that the mean time required to change an oil of a car is 14 minutes and a standard deviation of 6 minutes. It asks if we have 36 oil changes, 36 cars, and what is the probability the average time to change all 36 cars is 12.5 minutes or less? So for this, we need to use the central limit theorem. Okay. Notice the standard deviation is going to be 6. Okay, and I'm going to do this in math mode. Six over the square root of the sample size. Okay, and that's going to be 36. That happens to be just 1. That's the value of the standard deviation. Okay, so let's use this fact. So if I want to calculate this probability, I'm going to do probability, the sample average, okay, is less than 12.5. Well, I said I want to use the central limit theorem, so let's make the central limit theorem. Okay. Well, I think if I recall, the central limit theorem says this. I subtract the mean, so let's take my equation. So I'm going to take my x bar, and I'm going to subtract the mean, mu. Then I'm going to divide by the standard deviation. And let me just steal the standard deviation here, sigma over n. And now I want to compute the probability for this right-hand side. It asks about 12.5 minutes or less. And I know that from company records, the mean is 14 minutes, the population mean. Okay, so I'll subtract the 14. Then I said sigma over root n, this whole quantity in the denominator is 1. So that winds up to be calculating the probability a standard normal, a z, is less than negative 1.5. Okay. And now if I want to calculate this probability, I need to use a calculator. So I like this calculator, and I provided a link to it for all of you. And I want to calculate the normal distribution calculator, mean 0, standard deviation 1. I'm going to calculate it below minus 1.5. Okay, so I'm going to recalculate that, and it's 0.068. So that's the value that I needed. Okay. So there's like a 6.6% chance we'd have a sample average of 12.5 minutes for 36 oil changes. Okay. So that's an example that we had, and this is similar to your homework problem. Here's another one that's similar to your homework problem, and I think I'm going to need a new slide to work this out. Okay, so here I'm specifying, I have the same information. The mean is 14 minutes from company records, standard deviation of 6 minutes, and the manager wants to provide an incentive for the employees to work hard. He's going to pay each employee a $50 bonus if they meet a certain goal. That is, and that goal is to have an average oil change of less than a certain time. So why don't I state that? The goal is that the employee have a average oil change time of a certain criteria that gives them a 10% chance of winning. Okay, that's our goal. Okay, so I need more room here, so I'll do a new slide, and this is going to be our solution. Okay, and one thing that we're going to note is that 10% is going to be equal to the probability, a standard normal. So Z is a standard normal. And by the way, standard normal means that the mean is 0, the standard deviation of 1. Okay. 10% is equal to the probability Z is less than some value. That value is an unknown right now. Okay. But wait, I'm going to go to my calculator and I'm going to use this one. It says I want to find a percentile and I want to find the 98th. It says 1.28 is that value. I could verify 1.28. Is it? And it gives me a 10% chance. So the question mark, the known value, is now known. It's 10 minus 1.28. Okay. We are being asked to calculate the value of the sample average, which I'm going to call question mark here, so that, okay, this happens. 10% is equal to the probability, and I'm going to steal some things. So we're going to use the central limit theorem here. 10% is equal to the probability x bar is less than that unknown criteria. Well, I can apply the central limit theorem here by subtracting the mean, which is 14, and dividing by the standard deviation of 1. Okay. Now, since this is also known as a z distribution, I can write it as the probability z is less than the unknown value minus 14 minutes. Now the question is, what is the value of this unknown? It has to give me 10%, but wait, minus 1.28 also gives me 10%. Okay, so I have to conclude that minus 1.28 is equal to that unknown value minus 14. We can just do some algebra and say that the unknown value, which is the criteria, is going to be 14 minus 1.28. And that's going to be our final answer. So what is that? Like 12.72 minutes. So if their sample average time to change oil is 12.72 minutes, that'll give them about a 10% chance of winning. And this is our criteria. Okay. There's a couple other problems that are very similar to this, but with different wording. I'd like you to work out these problems on your own and try them on Canvas. Thank you.